welcome to our workshop. I really appreciate that you came here. Okay, welcome to the We Decide to Rewrite Legacy Data Type to Easy Platform Field Type. You won't believe what happened next workshop. Thank you all for, coming to our clickbait workshop. Let me just introduce us first. So, I'm Hrvoje Knežević. I have been working in Edgen for the last 5 years, and I'm currently performing a position of Senior Symfony and Easy Publish developer. Eddie is going to assist me. I believe that most of you already know him. He's like more senior than me. And we decided to prepare this workshop to raise awareness of the importance of rewriting the old legacy stuff to the new stack. For the past 5 years, I have been mostly working on the project part of job in our company. Eddie was more of, develop and create new stuff guy, while I was mostly working on real-time projects. And, first of all, I would like to do a quick survey. How many of you are using custom, so non-standard field types in Easy Publish? Okay, that's great. And have you ever how many of you have ever written the custom legacy data type? Oh, nice. Okay, so...
How many of you have written field type in Easy
Yeah. Okay, just one. Interesting. That's great. I was actually afraid that it's going to be boring because I was expecting to, get a more intermediate to advanced audience. So I was afraid that you won't hear anything new. The thing is, in a lot of situations, we were getting, requests for projects which were rather complex, written in legacy, and people were all like, oh, we heard about Easy Platform, we want to upgrade our project, can you do that for us? Yeah, sure, why not? And then you would get a project with, I don't know, roughly 50,000 or 100,000 nodes, and it's completely dependent on some custom legacy data types, which at some point the developers found, oh, this is great, let's use it. And then those same data types were never rewritten, and we had to do the job. I don't have to tell you how painstaking that can be. It is not at all easy to migrate some data type, some data types to another data types. If you have something, that's more convenient for you, you have to use the scripts. You have to, change the data directly into database. And it's really not easy. And on the other hand, a lot of those custom data types were never rewritten because, I don't know, the developers just decided, to let it go. Didn't ever bother to do that. So all of this job fell back to us. So today the idea is to show you how you can relatively easy rewrite all those data types to at least make them readable and writable in the new stack, so you can keep using them instead of having to bother with migrating content and stuff like that. So,
Sorry, you can also go for just read-only if you want.
Yeah.
If you need it, you don't have to implement write, because if you still use the legacy administration interface, the data type of legacy data type of writing will be just enough. But to actually display it on the front end, you will need at least read support.
Yeah, exactly. So. It's a lot of our cases when there were some legacy data types involved, we tried to at least make them readable. And if we would create the new installation, the new project, if we would migrate the old database to the new stack, to the Easy Platform, sometimes we would introduce our own field types, which we know and which we use. If we have the field type that's performing the same task, but still leave the old data type in at least readable state, so we can fall back to the old data and then simply force the editors to, to use our field type instead of the old one. But that's also, sometimes that's really not an option. So, okay, also this workshop is intended to be mostly coding. So before we get started, I would ask you, if you haven't done it yet, to go to your VirtualBox machine and go to the field types project and do a quick git pull and git checkout master.
It's reverse. It's git checkout master first and then git pull. Sorry.
Yeah. Doesn't matter. If they pull it, they'll pull everything. Yeah. Okay, did you do it? Okay, great. So, without further ado, what is the procedure of rewriting the legacy data type to the new field type? I'm sure that you are all aware that those data types can sometimes be incredibly complex, so you won't, at most of the times, you won't get the, something as simple as a text field type, with just one entry. It will probably use complex objects, complex operations. Sometimes some of the data types are even using the, some sort of backend API to get the data, and it can easily get really, really complex. So before you do anything, you need to figure out how the old data type works. So there are several things that you need to consider when you're doing it. For example, we decided to, go with the reverse engineering of the EasyTags data type because it's really fairly complex. It uses its own data tables in the database. It has several different modules, for administration for the front end. It contains several services. So as a project, it is pretty complex, but it pretty much also covers all of the, little things that you might have missed with something else, but we implemented it, so that's a good thing. So let me just do a quick overview of the old EasyTag extension. So we have a lot here. For example, a couple of types, a couple of things here. Other than just implementing the data type, which is the thing that was that is fairly regular. We also have a lot of PHP classes. We have custom operators. We have extended attribute filters. We have several methods. Yeah. JS core modules. Yeah. So really.
These are all, of course, related to the field type, but they're used for the administration interface and so on and so on.
Yeah, exactly.
So it was that it's complex, so it
Yeah.
It can show much stuff that we can cover with data types.
Yeah. So basically, what we are about to do is start with the value of the type. The best way to figure out what kind of data is data type working with and what kind of data is it storing in a database is to just check several things. Check the type, the is that type extend method. You should also check the database, because in some cases it's not just enough to check the code to see, okay, it's using this field or that field in the content object attribute. Sometimes it's not obvious at the first point, so you should always go into database, check what you already have there, try to get one attribute and modify it and see what kind of impact it had in the database. Just to get the feel how it actually works. So for the first thing that we're going to do is to check the tags type and see the methods. We have plenty of methods, but we can always check the methods, which is called object attribute contents. So this method is actually the thing that you would get returned when you try to output the contents from the object attributes inside template.
This is the attribute dot content.
Yeah. So you remember that dynamic fields that you always have in the easy content object attribute, which is response to dot contents. That's it. So if we check this, we will see that in easy tags it contains only one line, and this one line is invoking the static method from the easy tags class, create from attributes. Basically, what you get is, let me just show this. We have a separate class. We have a separate class which implements the data model for each tag. So basically, we're not handling the tags through the content object attribute by itself, but rather through these helper objects, which contain a whole lot of data. They have a lot of properties, which includes list of tags, tags count, and stuff like that. Also, if you have ever used easy tags, I don't know if you have ever used the easy tags data type, you know that when you return the content, that you will get the array. You will have another property that's called tags. It is actually a dynamic field which is generated, which returns the result of tags function. Where is it? And basically, it will provide you with the array of tags. So here it is. So this helper class will provide you with the list of tags, which in turn, when you invoke it, it will return an array of easy tags object, and easy tags object is actually the representation of that one tag itself. So as you can see, it's fairly complex already. And the easy tags object is actually the thing that we store in the database. So it extends easy persistent object, which is an interface, to the database, to the storage, and each tag object will contain field like ID, parent ID, main tag ID, keyword depth, path string, etc. So basically, what we will have to do is re-implement this easy tags object PHP, this class. And we will also have to, refactor the old content value in a way that we will create a value class returning us the list of tags, the array of tags, tags object. So I would now ask you to, check out to the step 0 branch. We'll be doing some coding. If somebody cannot keep the pace, we have prepared branches for each step. So if you don't make it until the next step, just do a git stash and git checkout to the next step, so you don't have to worry about it.
I will go around when you start the code to see if you need any
Yeah.
help, and if you need any help, just raise your hand.
Yeah, Eddie will be helping you.
I'll meet you and try to help.
Yeah. Okay, so once I check this out, we already have the app bundle prepared, generated, and when we check out to the step, do it. Okay, sorry, my fault. Git checkout step 1. Yeah, that's the one. So when you check out step 1, you will see that we got the core folder and the API folder. The common thing when you create a new field type is to create a structure like this. So first in the core folder, you will have the field type. Then
This folder structure actually mimics the folder structure inside the easy kernel. So
yeah.
It's easier to follow what is placed where and so on.
Yeah, so the first thing is we create this folder structure, and then we create the file called value.php. So this class will be the representation of your new field value, and if nothing else, this is required in order to, just have any kind of output for your new field. Just create this, this prototype. It only has, at the moment, it only has one function, the magic function to string, and then we will start coding. Another thing that you need to create is the API folder, where we have created the implementation for the repository, value, the tag objects. The tag objects, it was directly rewritten from the EasyTags objects. As you can see, the property names, the thing that we already had in the old persistent object definition, we have just mapped it to the new class. So we have ID, parent ID, main tag ID. We will re-implement those fields in our representation of our extension of the value objects in order to get the similar model. One thing that is actually important is when you are rewriting the legacy data types, take care that the outputs and the features from that data type are rewritten in mostly unchanged states as much as possible, because if you have people using some data type for years and then they switch to the field type, to the new stack, they are pretty much expecting it to work the same way, so that there are no radical changes. Of course, you can improve the interfaces, you can expose more data if you want, but when it comes to the point where you have to take this data and store it in the database, it must not change. It needs to stay compatible with the legacy stack. Okay.
The main difference between the old EasyTags object class and the new tag.php tag class is the fact that EasyTags object was the class that had the most logic related to fetching tags as well.
Yep.
So the class itself represented a single tag object, but it also had methods for fetching the list of tags, for fetching the sub-tags, for fetching the synonyms of the tags, and so on and so on.
Yep.
These things, all of those methods per field type and easy new stack standards moved to a separate service, and the tag class just remained a single value object with only data, no logic whatsoever. So
Yeah.
that's the main difference, and it's really the important difference.
Yeah, just to split functional. Okay, so first of all, we will create the tag class, which extends value object. I have already given you the comments on the properties, so let us create these properties in it. So we have the protected, protect, yeah. So.
Do you know how the value object in the new stack works? You have the protected ID and protected parent ID, and all of the properties are protected, but you can still access them by just by using the arrow notation without getter methods, because it extends the value object class from the easy new stack, which has the magic get method, the magic set method, which accesses the properties as you access them.
Yeah. I was getting to that, so yeah, basically what Eddie said. Okay, so we just create these fields, parent tag ID, main tag ID. We'll also have the array of keywords. Sorry? Oh, thanks. Okay, so after we create all these properties, as Eddie mentioned, the value object has some magic methods for getting and setting items. So we will simply declare several magic methods for setting properties, not setting, but getting properties, because we will do this class as, read-only for now. So we'll just implement the get methods and the isSet methods, so we can check if the property is set or not. So first of all, we'll create a public function. Sorry, I'm struggling with the Mac keyboard on VirtualBox with Linux. Okay. Okay, so if you notice, I haven't created a property keywords, although it is listed above. So we will create a convenience getter, as it is said in the comments, we will create a dynamic property which will actually return the result of the getKeywords methods. So basically, we need to check the name of the property. Okay, so in case the invoked property is a keyword, we will return the methods, which we will also implement, but let's just put this down here. So in case we have the keyword property, we will simply return the results of the methods, and in all other cases, we will simply invoke the parent magic methods and pass the property parameter to it. So right now,
This getKeyword.
oh sorry, yep, I don't have it yet. And we will also declare the method for this. Get keywords. As you are well aware, you also need to take care, in this case for the tags, you also need to take care of the language handling, usually, because tags are translatable and they can, be in, you can get tags for, you need to get the tags in languages that are able to be presented on the front end. So in the regular easy tags, this method contains the parameter which will not be used at the moment, but it takes the language code. And basically, we need to take care of it ourselves, so we can check if the language code is passed to the methods, and if not, we can always fall back to the main language code, and in all other cases we'll display only the one that we have set. So we can check if language code is null. In that case, we'll return language code equals this main language code, so we'll return the property, and we will also check if keywords contain the entry in the given language code, then we will return these keywords, and in all other cases we'll return an empty result. So we will just say if is set this keywords
FNG, out GR, out FNG.
yeah.
Okay.
Yeah. That's it. So we'll check for the language codes. Sorry?
Variable language code, not the string.
Oh, sorry, right. Thanks. So we have this language code. If we have keywords in this language code present in the object, then we'll simply return the language code. And as I said, in all other cases, we simply return null So no keyword found in the given language code. Okay, that solves the getter, and we will also make a method which will check if the some property is set. So is set, which will return parent is set in all other cases except when it comes to property keywords. In which case we will simply return true always, and for all other cases we will fall back to the method from the value object class. So we got another thing left, and it is the implementation of our dynamic fields, which we will do by defining methods for a method for getting properties. So we'll implement a method getProperties, which in every other case will invoke the parent getProperties. Okay, what happened? Okay, great, my laptop froze. Who would expect that?
Maybe just the
Nope. Nope. It's dead, Jim. Ah, come on. Yeah, this was really not expected. Completno. So, as we were saying, we have the method getProperties that is also defined in a parent, which we will use to define our dynamic properties. We'll say that dynamic property that we have is a keyword, so we'll just pass it in the arguments directly as default. And sorry, just a sec. And we will call the parent method getProperties, which will basically return the property value. And we also have to define the method that will return the keywords. So, sorry? Did I? Get keyword? Oh, I did. Okay. And with this, we're done with defining the model for the tag objects. And this tag object will be actually used in our other file, which is the value. So the value methods, as I said, is the thing that will represent the value of your field when you invoke when you try to print out the field value or invoke the EasyFieldValue operator in Twig. This class will handle those requests. So the value for the tags fields will have a single property. As if you remember, in the old stack, in the legacy, we were returning the result of EasyText create from attribute, and EasyText create from attribute methods was returning the array of array of tags. So basically what we're about to do is we don't need the special class, another special class to handle that. We can simply declare a property, public property, and state that it is an array. So in case when we have an empty field, we will simply return the empty array, and in the case where we have some value in the tag, we'll be returning the array of tags objects. So we also need a constructor. Construct. We have we'll be accepting the array of tags as an input, and we'll also do a quick check just to see if the accepted item is actually an array, and if it is,
there's an error. You have double equals sign.
Oh, yep. So we'll simply check if the tags that we have accepted is array, and if it is, we will store it in a property. Okay, this tags. And that's it. On the other hand, we also have these toString methods, and the toString methods is something that will, if you invoke if you try to output the value of the tag, it will at least, print out what we have in this toString magic method. So it is the basic value that can be used for representing a value, but not the actual content, So that's just something to print out. So in the toString methods, we can return the list of keywords for the tag. So we'll just have a comma-separated list of keywords of all the tags that are applied to some tag attribute. So we can implode, for example, implode with the array map, where we will call a function accepting our tag values.
This toString method is only a simple representation of the tag value. In most cases, you will actually use your Twig templates to render the output of the tags field type. This is just in cases when someone casts your value into string or displays the value in Twig template or something like that. So
typically this is used to generate the URL alias.
Oh.
Typically this method is used to generate the string for the URL alias and the content name. Not always, but this is what is usually done.
Okay, thanks. And let's see what we have forgot. That's it. So basically, we will simply take the array of our tag objects, and for each of those tag objects, we will get a keyword and return the list of tag keywords separated with a comma. And we will also need one another convenient methods, which is the magic method is set. So when you invoke the request to see if specific property exists, it will, you know, just return you true or false. The original, sorry, just for a sec. Okay, yes, sir. No, so wait, we have construct, we have the toString, and we have, no, sorry.
I think that's...
Sorry, wrong, yeah.
So this method doesn't...
No, we have already declared it in the tag, in the value object. Okay, so after this, you have the value defined. Second step, so this was the step 1. After this, we have the value representation. After that, we need to declare another file, which is a type class. And this type class is pretty much defining everything that you had in the old data type. So this is the method which will define the type as itself. So it will, you will be able to retrieve the, define and retrieve the field type identifier, the human readable name. You will be able to check if the attribute is empty, and you will be able to actually input values and store them in the, you know, in the database. Not just yet, but we will create, we'll be able to create the value object from the inputs. And there are also several methods, 2 methods which are called from hash to hash. Now, if you are using any sort of IDE, okay, so for you that haven't managed to finish this, just go to the console and type git checkout step git stash and git checkout step 2. I have already prepared the type class for you. So we place it in the same place where we have placed the value representation. And if you declare this class which extends the field type, if you declare it without any methods, and you're using some sort of IDE, it will tell you that there are 7 methods that must be declared abstract or implemented. So these are the methods that you will have to implement, with one addition, which is always good to have, and that's, I think it's empty value. No, is empty value, okay. So you will have another methods that is called isEmptyValue. This very method is actually used when you type isFieldEmpty. So when you invoke that function in Twig, or if you check for the if the field is empty in the PHP, you will actually be invoking these methods. So we have several different methods. So get field type identifier, that's pretty much linked directly to the legacy. If you check the legacy data type, at the top usually there are declarations for data type string, for data type string, for the name of the field, human readable, and these properties are mapped directly into the new stack. So what we're about to do is create the get field identifier. It will simply return, in our case, easy tags. So we are keeping the same name as we had before. We can also have the get name methods, which will return a human readable name for the human readable string representation of the value, and we will simply do return sure that it is string. And simply return the value.
Now we're using the string method from the
Yeah.
field value.
Yeah, exactly. We also have the getEmpty value, which will simply return an empty value. So we won't be passing any tag object array. And we also have the isEmpty value, which, as I said, it is mapped to the easy is field empty. So it is also receiving SPI value, and we simply need to check if what we got is basically, is it empty? So in this case, we can check either we have a null, which is always a good check, or we actually have the value object, but that value object has an empty value. So either we won't be having anything in the text property, and to check this, we will be using if our tag property from our value is equal to getEmpty value tags. So that was the purpose why we had this getEmpty value method, which is, you know, pretty convenient. Sorry, this is or. Where are you? There we go. And we also need a couple of brackets here. There we go. Okay, so the next order of business, I don't know how much time we will actually have to code all the way through. Yeah, the first stop is in 30 minutes. So basically, the other deal of business is to make sure that we can write new values into the field type. So just to speed things up a bit, I will cheat a little. No?
You did not check out.
I didn't? Oh, right, the space. Okay, so just move this here. So we have the field type identifier, we have the getName, we have the getEmpty value is empty value. Now, when we create the value from inputs, we will be providing an array of. We will be creating an input which we need to check if it is an array. If you remember, in the old legacy data type, we were always handling tags through an array of tag objects. So we will be doing the same thing here. So if it was done in legacy like this, we will simply replicate this. So we will check if the input value is array, and we will check if all the items in the array are instance of tag. So basically, we are forcing the user to use the same system as before and always prepare a tag object before he passes the value and tries to store it in the database, which is actually convenient. Another methods.
Just a second. The main point of this method is to make sure that we only deal with the value object.
Yeah.
So the point is that the user can provide the different input formats for your field type, but basically you convert it always to the value object. So the field type itself always works just with the value object. So if the user provides the array of tags, and if just a single item in that array is not a tag object, we will not accept the value and we will just return it. If the case is that the user provides an array and all of the items in the array are text objects. We construct the value from it and we return the value. If the input value is not an array, we just return.
Yeah.
So we assume in this method that the input value is a value object if it's not an array.
Yeah.
There is a separate method that actually checks if the input value is a value object.
Yeah. But as we said, easy tags are a bit more complicated than usual. For example, if you have the simple text line, you would simply check, if you got anything, and you would just pass it to the property text of the new value. So you would pass it to constructor. So
in theory, you could also use the array of integers, for example, in this method.
Yeah.
And use the integers to load the tags from the tag service and then construct the value objects from that.
Yeah. Another reason why this is also done is that by using tag object you cannot miss if if you're passing values, they will get pretty much instantly validated when you go through some sort of specific objects for this, instead of having to handle that stuff in the type itself. Another thing that we have is the check value structure. So this is a method that will throw an exception if the structure of your value, of tags value, is not in expected format. So this is just a bit of validation where we will check if the value tags is an array. That's the first thing that we need to check, and then we'll also check for each value within the property and see if it's an instance of tag. So basically we are making sure that the inputted data is not invalid. The methods from hash and to hash are actually interesting. So basically what these methods do is they provide you with the simple serializable representation of the field. Since the storage layer or the storage gateway is actually implemented in the SPI layer, we cannot deal with objects, we cannot deal with the complex PHP structures. So basically these methods are providing you a convenient way to switch between your complex structure and something that is simple and serializable, so it can be used either in a storage or in some sort of REST interface or stuff like that. In our case, tags as it is are pretty complex, so when we want to switch them to the serializable value, we will provide the array of tag representations which are also arrays. So we'll just extract the values from the tag object and add them in a simple PHP array because it can be serializable. On the other hand, the from hash methods will instead accept the array of arrays, and in the end it will convert them to the tag objects, back to the tag objects, by setting all the values from the array to the properties of an object. So we will see why these two methods are actually pretty important, because they are actually used at a point where you say, okay, I have prepared my value object and now I want to store it in a database. So the data that you will get there is actually taken from hash, from the from hash methods, and from the to hash methods. And when on the other hand, when we are returning the value from the database, then we are actually using the to hash methods to give the serializable content, which can then be converted back to values. So
these two methods are replacement for 4 methods in the legacy data type.
Yeah, actually.
So you all develop the data type, so you know those 4 methods. These are from string to string, and serialized content object attribute and unserialized content object attribute.
Yeah, that's right. So you have the equivalent in the old stack. So serialize, unserialize. And also from string to string, which was, as you know, it was used for several purposes, amongst others. There was also, it was used for indexing content in the search engine.
Import-export.
Import-export, any sort of interface where you needed a simpler format.
For all those cases, you will use from hash into hash.
Yeah. For example, if you want to expose your values in some sort of API which handles, JSON arrays and stuff like that, you would simply get the hashable method and you would just serialize it. It's simple as that.
The original text bundle. So we are rewriting the text bundle here, but the original already written text bundle actually implements the whole read-write REST API for tags and the field values, and of course it uses these two methods for exporting and importing tag objects.
Yeah. So once you have created these methods, we also have some. So you don't have to implement everything. We have also added two additional methods here, which were not mentioned before. So it's a get sort info and is searchable. So this sort info is the thing that is also directly mapped from the old stack. If you remember sortable key, you have these fields in the easy content object attributes table, which are called sort key int and sort key string or something like that. And in the old data type, you were able to declare if some of the fields, which field is used for default sorting of the items. In this case, easy tags have their own external data tables, and they are not using the content object attribute table by itself, so they're not storing any data in the attribute itself. So in this case, it is irrelevant. And also, we have a method which is used internally, which says if the field is searchable or not. So this is used deep down in the kernel.
This is used actually in the platform UI to enable a checkbox.
Yeah, also the checkbox.
If the field is searchable inside the content type, this is not. You would think it is, but this is not actually used by the Solar search engine and so on to signal if the field is searchable. The search. What's the class name?
Indexable.
Indexable
interface.
Indexable is interface. So if you implement the indexable interface, then you will get the search capabilities of the field type. This is the method just to enable the flag in the platform UI for now. Yeah. Maybe it will be used later, but for now it's just the flag.
Used for another purpose later. Yeah.
If we have a question, sorry.
So that checkbox will override this or not, or it doesn't have anything to do with this.
What do you mean?
The checkbox, when we are defining the content type, there is a checkbox there if this field type is searchable or not. So, will that have an effect on this, or because we are just statically returning true here?
This just enables the checkbox. It doesn't
enables
check
the checkbox.
It doesn't check it.
It doesn't set the value, it just enables it.
It just enables the input element.
Yeah. For example, if you had, I don't know, some complex field type which is not supposed to be searchable, like, I don't know, perhaps a file field or something like that, where you don't need to, search inside the content, then you would set it to false and it would be disabled by default. You couldn't make it searchable. That was actually, in the old stack, we had a whole lot of problems with indexing content containing files because most of the time those files had invalid headers and they would break the Solar indexer and stuff like that. So it was convenient to make them non-searchable. Okay, so after this we already have the entire model of our field type sets, but this is still only in the PHP layer, in the code layer. We still haven't stored any values in the database, and we will have to do that as well. Okay, so in the next step, we will implement the first step to the persisting our content in the database, and we will implement two additional methods in the type class, and we will also add some validations. So if you remember, any field in the easy publish can have some sort of settings, additional checkboxes in the interface and stuff like that, where you can define, for example, constraints and stuff like that. In easy tags, we had several restrictions. You could have chosen if you want to, for example, add tags only from specific tag subtree. If you want to limit the number of tags that the user is able to add in the field and stuff like that. So these settings were defined and written in the easy content class attribute table, because for each field you are able, to use two places by default, the content object attribute and the content class attribute. So you can define something on a global level, and then the data goes to the content object attribute. So this is now if we have anything. In the step 4, we have the step 3, which is completed. So, just to give you an idea how complex that can be, we have the protected property. This is the default name for a setting schema, which contains all the settings that we are able to set for the field. So, for example, if you were to add the tag in some article class, you could say, okay, I want only tags from the category subtree to be added in this field, and I also want the editors to be able to add only 3 tags, and I also want the root tag of that subtree to not be visible to the user, and they're not for them to not be able to add it as one of the tags, because by default it would include the category tag and then also all the category text which are under its children. So these properties we can, if we open the legacy data type, those properties were also defined here at the very top of the data type implementation. We had subtree limit, hide root tag, max tags, edit view, so that's basically the same thing that we're doing there. And we also had, it was sort of like convention, but to declare this in the constants, it's not a rule, but if we check the initialize class attribute methods in the old data type, we will see that this will be a good point to check which properties are used for class attribute and where they are stored in the database. Easy content class attribute table actually contains a large number of free form fields which can be used for storing such settings in it. So we have several integer fields, we have several text fields, and a lot of legacy data types actually use this feature. They're storing their own configurations inside. So this would be the good point to check where they are stored and which properties are used. And we will declare the setting schema, and we will also have to check these settings when we are storing the value in the easy. So these settings will be used as sort of constraints for the data, and to implement that we have to declare the method which is called validate field settings. This validate field settings method receives the array of field settings that we have declared, and for each field setting we will have to make a small piece of code which will validate the value we have received against those constraints. So this is completely custom, and you define how it will behave. So for example, the subtree limits subtree limitation, we'll have to check if the tag is actually located within the parent, somewhere in the subtree. It will have to check if the value of the subtree limit is larger than 0, if it is an integer, because in settings we have declared that default value is 0 and it has to be integer, and of course it needs to be a real tag. So we have to check if perhaps the user, passed the invalid value in it. This field settings array is actually passed when we create a new field definition. Yeah. So so after we do all these checks, and there's really a lot of them, we have to check against all of them, and in the end we return, if we have any errors, we will be returning an array of validation error objects, which will describe us what is the problem. So, yeah, you wanted to say something?
Yeah. You might have noticed that the setting schema up at the top defines for each of the elements what type it is.
Yeah.
This type doesn't necessarily mean that you will only be able to transfer the integer for the subtree limit. For example, it only uses its only purpose is as a type hint for user interface. Yeah. For example, the validate setting schema actually validates it's an integer.
This setting schema is it's also free form, so you can add properties which you want. Of course, these are hints for the users, but you can actually store additional info in it and use it for validation.
Yeah, sorry, just one question, because this is all now for the field itself. Mm-hmm. But if I would have a field or a custom, field type, mm-hmm. And then I would like to define a default value for one instance of that field. Yeah. So where would that be best stored?
Default value. That would be this in the setting schema. That would be stored in the setting schema.
Okay.
Yeah. There are actually two arrays. There is a setting schema and a validator configuration schema.
Exactly. I think I have added it. Yeah. You see the comment in the with input validation. So in our case, thanks for reminding me of that. In our case, we have an EasyTags field which doesn't use any of the values from the. It doesn't store value in the content object attribute. We pass tag objects and then we handle them separately. But if you had a field which actually stores the value in the object, then you would have to use additional two methods, which are called validate and validate validator configuration. So I would like to show you this, but I will show it on some of the existing data types from EZ, because it's
the main difference between two arrays. Setting schema actually stores the settings, as is implied. Validator configuration schema stores the configuration for validation of the field value. So we use. Can you show me the setting schema of the EasyTags?
Yep. Hold on.
We have four values here. Sorry, we have four values here. Subtree limit and max tags could be used to validate the field value. And hide root tag and edit view are just settings.
Yeah.
So basically, we could have separated this into two arrays, but we didn't because of the legacy.
Yeah.
So it was the legacy stored all of the values in the easy content class attribute, so we just defined everything in the setting schema. We didn't want to change that because of the BC breaks.
Yeah.
Question.
Right now, all these settings will be displayed as checkboxes in the interface at the end.
They will be displayed as type hinted here. So if the type is integer, they will be displayed as a text input field. Yeah. If the type is Boolean, they will be displayed as a checkbox. That's why I said earlier that they are only used as a hints for the user interface, to actually check if they are the right value, you need to use the validate setting schema.
So, for example, if I want to have some setting which contains multiple values that from which user needs to select one value, for example, some drop down or something like that for a setting.
I guess you would use an array, but how would you populate the array would be used in the you would be defining in your Twig template and so on. So the array will probably mean that the select box will be appeared, and you will fill it from the template. I'm not sure of this, but I presume.
Okay.
I'm not that used to platform UI, so I'm not sure exactly how it functions.
Yeah, we're still trying to grasp that. Okay. Okay. So since we are using the configuration field settings validation to actually see if the tag value is stored. Oh, right. We were talking about validates. I was interrupted. Yeah. For example, the integer field value. It will have something that is called validator configuration schema. You can define the restrictions of the fields here, and you can also use it to, for example, define what you ask the default value and stuff like that. So, for example, for integer, we have the configuration schema. It always has this structure. So we declared the list of validators. For example, integer value validator, where we say it has two properties. It has minimum integer value and maximum integer value, and we will be using by default they're null. But we can use these values to restrict the field value to specific range of numbers, and we have two methods, validate and validate validator. In the validate methods, we will be invoking. We will be invoking this validator configuration, and we will be testing the value against the constraints from that validator. So basically, this part of code, should you ever need it, you can always check within the easy publish kernel how they have, implemented it for some simpler field types, and then you can.
Integer is most simple, so
yeah, integer or text field
where
are
you
simple.
can look into.
Yeah, so that's basically the thing that you can reuse. Just take a look how they have created it and try to copy it, because it's field specific, but it's a good pattern to start with from some simpler field type. And there is also a method, we are validating the data itself, but we also implement the validator configuration methods, where we will create a check. For example, if I'm storing the integer field and I'm applying the, what was it called, integer value validator, I want to check if the configuration that I'm getting for this field is exactly what I have defined upside. So I want to see if configurations that were passed through are actually called integer value validator, and they're containing the elements which are called min integer value and max integer value, and I want to check if those values are actually integers, because if I pass through the wrong configuration, I might end up with storing something that wasn't supposed to be stored in the field. So this is just a way, to test your configuration and your validation at the same step.
This method is basically a validate setting schema for settings.
Yeah. Exactly. Mm-hmm. Okay, so that would be the case if we were using the internal fields from content attribute. And as I have mentioned, since we need to validate the subtree, here we have the first point in our code where we actually need to work with tags. Yeah, it figures. Okay, so validate field settings. At some point where we are checking the subtree, we have the line where we say, okay, we're checking if integer right now. So, but there is also a line missing. We will have the point where we will need to check if the integer that was passed as a subtree limitation or the parent tag ID actually represents a tag. And at that point, we will have to also use the tag object, or rather load the tag object from the database and check it against, if we manage to actually fetch tag, then we'll be sure that this subtree limitation is valid. So in order to do that, we will have to make a bridge to the storage. And this will be the next step for us. But just to show you, right now we have also these methods which are converting a value, so the PHP object value, to persistence value, which will eventually get stored in a database. These two methods, to persistence and from persistence, as you can see, are using are referencing, in our case, something which is called external data. So the field value will always have three properties: data, external data, and sort key. These fields are actually mapping the content from the storage to like this. So data field actually represents the data that is stored within the content object attribute itself. So within the table is the content object attribute in its internal fields. External data can be any sort of custom table or custom storage that you are using. So if you're trying to write down the data or fetch it from the database, but it is stored outside of the content object attribute table, it will be in external data. You will define it in external data.
When he says outside, he really means outside. Everything
Yeah.
that is stored outside of easy content object attribute would go through the external data.
Through the
Even
external
the
data.
custom tables which EasyTags uses.
Yeah. And the third field, sort key, is something that it is just a declaration if you want to return the default sorting key. So the fields sort key int, sort key string, which we are also not using here because we have the external tables, so we don't have anything to sort out. And this is the first step in connecting your field type with the actual database. Since we have 5 minutes, okay.
We can take a break because in order
Yeah,
not to break
I think
up
I think that we could take a break right now. So is it okay with you? In 15 minutes, so we're back at 11:10. We have created this from persistence and to persistence value methods, and we have described how you can validate your inputs and how you can validate your value structure and settings. And now for the next step, I will simply just display this. So since we're working with the tags objects, we need to have some sort of the service which we will be able to use to actually fetch tags from the database and the tag objects. So not the value, but the tag itself, which is the value that is written inside the field itself. So tags bundle actually implements all the methods that you had in the legacy that were implemented. Yeah. Oh, dude. Hold on just a sec. Yeah, of course. Mac. Never mind.
It's not in the default settings, it's just settings.
Mm-hmm. Never mind, I will switch to. So we'll skip this because we probably won't have enough time. But we have to provide some sort of interface to fetch tags, to load the tag objects, to handle data, to fetch children for the tag and stuff like that. So this is a fairly complex piece of code which basically implements everything that you had in the extension. We had the tags object class. And in the legacy, you had the persistent objects class, which you were extending when when you wanted to, create a CRUD model for anything that is stored within the database, and all the methods for creating, fetching, updating, removing objects from the database were implemented in this persistent object. On the other hand, when we migrated this to the new stack, we implemented the tag object to represent a value, and all of the methods were placed in the separate service, which is injected in a container. So this tag service is actually the CRUD interface for the tags itself, or rather for the for creating or updating tag objects from the from our custom database tables. So in our case, since it's really complex, we have simply created the dummy service. So we have created the interface for the tag service, which in our dummy case contains only one method for loading tags. And since we decided not to re-implement the entire thing because it's pretty complex, we would need to implement some additional layers and stuff like that. We have simply created a dummy method which returns the tag object. Why have we done that? Well, because when we are checking the configuration in the tag, when we are trying to validate the subtree limits, we need to figure out if we are actually getting the tag ID of an existing tag. So logically, we would need to check if we can actually load the tag object from that ID, and we have simply added this piece of code in the condition checking, where if we don't get the actual tag, we would render the validation error. That is a constraint that is crucial for the fields to function as intended. So after we have fixed the validation, after we have implemented the validation of the data, the next logical step would be to create a legacy storage engine converter. So legacy storage engine converter is a special class which provides the interface to access the data from the storage itself. And since we were talking about storing the data in the content object attribute and content class attribute tables, this converter class actually provides us the interface to access both of these fields and to store values in it, to pass values in it, if of course you have anything to add inside. So
this is the case for legacy storage engine, of course.
Yeah.
The point of the converter method is that you can of course have many converter methods, converter classes, one class for each storage engine. So in Easy Publish 5 and 6, we currently have a single storage engine, which is a legacy storage engine, and thus we only have a one converter class. Yes. When we introduce the support for another storage engine, we would implement another converter class that works with that storage engine.
Yes.
As Hrvoje said, the one we are implementing here provides access to easy content object attribute and easy content class attribute tables.
Yeah. So the default tables that you have in EZ. So basically the methods that we were mentioning are grouped like this. You have the two storage value and two field value methods, which are providing the interface for handling the data from content object attribute table. And then you have storage field definition, two storage field definition and two field definition, which allows you to convert data to the for the content class attributes table, and the get index column, which is sorry, I need to switch here. So the get index column, which returns the name of the index column in the attribute table. So how does it work?
We're not even sure what it's used for.
Yeah, I think that this is just you know, the method that was intended to have some purpose in the future, but I'm not sure if it is even used
I don't
anywhere.
think it is.
Yeah, but the main thing is you need to implement the instance of the converter interface. The methods, as you can see, tags do not store anything in the content object attribute itself, so we just left those two methods empty because we don't have anything, you know, to convert to it. But on the other hand, to storage field definitions and to, where is it? Oh, here. Okay, so the methods to storage field definition and to field definition are performing this. So we are passing the storage field definition, which is basically defining the entries in the database, and we are passing the field settings that we have defined in the field definition. We're passing it and mapping them to the fields in the database. So storage definition implementation contains data float 1, 2, 3, 4, data int 1, 2, 3, 4. So all the fields that are actually existing in the database are exposed here. And on the other hand, two field definition methods will retrieve those fields from the database, and you will be able to convert them into the field settings that we defined in the type, and you know, just fetch those value and return an array of field settings. For the data storing, we can always check how it is done in Easy Publish. So, for example, for the, I don't know, text line, core, yeah, core persistence, hold on.
Legacy.
Let's see, content fields, value converter, text line converter. So it has the methods to storage value and to field value, and also storage field definition, because we have a constraint on the text line. It is a constraint on maximum number of characters or the default value, I can't remember. Yeah, but to storage value, to field value are actually passing the data from the field value. If you remember the fields, the data, the external data and sort key. So we are passing those values to the storage field value and vice versa. So we're actually defining which piece of information will be stored into data text, or data int, or data float. So these are the fields that we have in the content object attribute table, and of course the sort key string or the sort key int, depending which one is actually used. So by doing that, you're actually, for the first time, you're providing interface to the database. And in the next step, you need to actually, hold on. In the next step, you are, just another notice here. So if you are not certain which fields are actually used for the content object attribute and for the content class attribute, you should go to the legacy data type implementation and check the methods like initialize and store stuff. So for the class attributes, it's initialize class attributes fields or something like that, or store content class attribute, and for the content object attribute, well, initialize or store content object attribute contents. So that's one way, and another way is, as I said, if you're not sure how the legacy data type actually works, go to the database, create an SQL query to get one attribute, then try changing its values in the administration and see what changed in the field. That's the way that you will be absolutely sure what is actually going on. Then the next step is to actually create a gateway for the storage. This is the methods where we are finally, providing the actual values that we want to store in the fields and pass them through into the database itself. So how does it look? We have to create back to the code. So we have to create two files. We need to define the gateway class, where we will basically define the CRUD operations for the fields in the storage. So basically, it doesn't have to be the legacy storage. We can have all types of storage, and we are defining the model for it. So we define the interface for it, and then we just extend this class and perform whatever needs to be done to actually store this data in the database. In our case, we have three operations. One is the store field data, get field data, and delete. So we have the store field data, which is used for creating and updating fields. We have the get field data, which is just a select, and we have a delete field data when we want to remove the value. And then we will implement the legacy storage gateway. So this is just a model, and we have a legacy storage gateway which is designed specifically for the legacy storage or for the Easy Publish database. This storage class will actually extend the regular gateway. We will connect to the database, so it sets a connection to the database. And after that, we will implement the, so it has a set and a get connection methods, and which are fairly generic. I think that you can also check an implementation of the legacy storage gateway for the existing field types, and just take it as a pattern which you will just fill out with your values. And we have those methods for storing, updating, removing, selecting. Sorry. Yeah. For storing, updating, or removing data from the database. So basically, what we do here, we are performing the exact same thing that was basically done in the tags service and tags object before. We had a persistent object class which was providing us the direct interface to the database. In this case, we have this. So you remember the methods from hash to hash. Well, those methods are used to fetch the data into the gateway and then storing it into the database. So the same serialized content that we have provided with those hash methods will actually be used here. Of course, it will simplify your job. You won't have to work with tags and stuff like that. You will get, since I have said that the storage is actually implemented over the SPI layer. So this is the reason why we use from hash and to hash. And we will get the fields with those three: date, external date, and sort field properties. And we will actually create queries directly into the database in order to fetch this data. Which data tables we need to use and what these queries should look like. you can always check in the legacy implementation and simply rewrite it into the new model. So if we check the or is it extension, easy tags, data types, but rather, yeah, we should check it in the kernel class. You actually have the possibility of seeing this code and rewriting it. Hold on just a sec, please.
It should be in easytags.php.
Yeah. Is it?
Yeah.
It's somewhere.
There's a whole lot, a bunch of SQL.
Yeah. I remember it somewhere. Oh, here we go. So, for example, create from attributes, fetches the text for a given attribute and locale. So we have a select query here, which we need to rewrite. If we want to store the data, we have, you see it's rather long and complex, so it wouldn't make sense to try to rewrite it right now. But for storing, we are also fetching tags, and then we are using the easy tags objects. Oh, create and link tag. Okay, so all the SQL queries, at least for the easy tags, is located here. For some simpler data types, it probably won't be that complex. It will just be, storing in the content field. But if you have any kind of external data tables which are not, the regular easy data tables, then you will have to implement this storing in here. So where is the gateway? Close it all. So we have the interface and we have the implementation of those methods. And this is once you implement this step, you are always returning the values back into the field value in hashable format. So, for example, when you load a tag, you are actually fetching a bunch of entries from the database. And once you get your query results, you're just, building the same format of the data that you have already defined in the toHash and fromHash methods. So basically that's the same thing, and you are returning the array in the end, which was our designated format. Okay, that's the storage stuff. I would really wish if we had enough time to go through coding all this, but I think that we just won't be able to make it. So I said from hash to hash, and there is also, when you create a field, you might be able to display it, and you might be able to create it or update it. But if you want to use it for searches, or if you want to index it for the search service, you need to define, to implement a class that is implementing the indexable interface. That's the thing that Eddie mentioned. So with the type and the is indexable property. So this is actually the thing that you need to use search service for text-based searches on field and stuff like that. So these methods, not that one. So these methods is actually defined in the field type tags. We define a search field PHP, which extends the indexable class, and We have several methods. We need those 4 methods to actually implement it. So, for example, the getIndexData methods will actually get you in the index data for field for search backend. So basically, we will take our serialized formats. So in the legacy, we had from-string and toString methods, which we were using to pass the string representation of the data to the search engine. EasyFind extension was using the toString to index fields in the Solr engine. And of course, if you had some more complex format, then you would have to define your own fields in the Solr schema and then link them. And EasyTags was one of such data types. But in here, in getIndexData, we are actually fetching the external data, parsing through all the keywords for each language, and we are just, checking if we have the keyword in a designated language of the site access, and returning in the end, if the field is valid and we actually have some data that is indexed for search, then we can define the search fields. Hold on just a sec. We can define the search fields. The old legacy easy tags had several fields in the Solr. The tag keywords, the tag IDs, so you were able to search the fields using IDs, using keywords, or even using parent tag IDs, and of course you could use tags for the full text search. So the fields that you see here, there are several types of fields that can be used for indexing content. So you can have, for example, multiple integer fields, which will take the array of integers. You can have multiple string fields, which will take array of keywords. And by defining these fields and returning them from the method, you're actually defining the way and the fields where your data will be stored and which will be used for searching the content. We also have the fields tag text and full text, which are used for full text search. And as you can see, these fields are defined as full text fields. So we already have a format which is called full text field, and the result of this search field will actually be, taken and merged into the general purpose full text search field. So that's actually giving you a lot of flexibility. And you have the getIndex definitions, which will actually return an array of fields that we are using. So just the definitions of the fields that we are using to index content and to perform a search on it. Also, the method default match field. That is the method that will give us the name of default field to be used for matching, which means in our case we are passing the comma-separated keywords in this tag text field, and we can use this field if we want to perform a search in the search service. So if we want to perform fields filtering,
I think it's used with the field criterion.
Field
right?
criterion, right? Yeah, that's the word. Yeah, and the default sort field in our case is the same as default match field. So if you define this class, it is really you can always take also some of the existing field types. It's really not that difficult to implement this, and you can quickly get the criterion out of the box to filter out using your.
And the best thing of all, this class is used for all storage engines.
Yeah.
For all search engines.
Search engines.
So in legacy, you had to implement in EasyFind a handler to return the data that went to Solr directly. if there were another search engine, you would need to implement another class that would return the data that
Yeah.
went to that search engine. This class is unique to all search engines, and
Yeah.
the internal search engine just converts the data into its own format.
Yeah, exactly. So it's pretty cool. Okay, after we define the indexable class, we have pretty much everything that is crucial for the usage of the fields in the new stack. Well, except we still haven't implemented any sort of template representation. So in order to output it, we will have to define the templates. But first, we have created a whole lot of classes. So the next step would be to link everything together. So the legacy storage converter, the gateway, the field definition, the field value, of course the tag service, which is in this case is custom. We need to inject all those, define all those classes in the configuration and inject it as services. So I think that would be our next step. Yeah, exactly. So we'll finally connect everything that we have implemented, and we're going to register our shiny new field type. Okay, so what we need to do is create a bunch of YAML types, YAML files. So we can just check out to, this is the step 8. So we should have everything implemented in here. And then we're simply going to create several files here. So we already have the services YAML, which is the generic one. But we want to, separate these settings so it would be easier to find, make more sense. So first, let's create the field types YAML. And in the field types YAML,
just a second. The structure he's creating now, the structure of these YAML files, also follows the easy kernel.
Yes.
The easy kernel structure. It's not, of course, mandatory. You can, of course, write it in the same file.
I mean, if you want, you can use services YAML and just write everything down in it. But after a while, if you have, when you check the original tags bundle, there are so many services and so many features used in it that you simply get lost after some time. And so we will define the field types file. We will inject it later. And what we need to do. So we have implemented the field types. So we need to define easy publish field type, easy tags class is bundle. No, not that. So we have to register our type, right? Then we have also defined the external storage, and we have defined the indexable class. So we'll also be adding these here. So easy publish field type, types, fields, something is wrong, wait, field type, right?
It doesn't matter really.
Does it? Okay, never mind. So we define the indexable class for the easy tags. We have called it search fields. There it is. And we also have the external storage. So easy publish field type, easy tags, external storage. Yeah. Which was defined in the legacy field. The tag storage right here. So all the files that we actually need to include are located in the core field type, the field type folder. So tags storage, that's the one. Okay, and we need to register them as the services. So, just we'll define the easy publish field type easy tags service. We will map the class, and we will have to define, if we want our field type to get registered, we need to say that the parent is easy publish field type. That's it. And our type accepts the arguments. If you remember, we have created the dummy storage, tag storage, which is passed in the constructor of the type if you do not have a tag service, yeah? So if you do not have any sort of external services that you are injecting in the types, you can skip this argument part. There is also one specific thing with tags. When we were mentioning the field settings, we have one of the settings which is called edit view. So basically we're not setting it anywhere rather than to the default value, but this set edit views method is actually invoked when you are injecting the service. It is invoked to set the default value of the edit view. So the method set edit views I haven't mentioned before, but it's really not that relevant right now. Set edit views just sets the default value of the available edit view, or rather past value of the edit view, or falls back to the default value if it is not set. That is the thing, Eddie, you have implemented it. It's related to the interface.
It's related to the admin interface.
Yeah.
It's not really.
So it's not really
available yet, but it will be.
Yeah.
Soon.
So right now I'm just gonna skip that. Yeah, I will just skip that. So we need to pass the argument, which is easy publish API service. Oh god, this keyboard layout is killing me. Okay, and in order to make it registered till the end, we have to define a tag. We have to define a tag with the name easy publish field type and the alias. It doesn't really matter, but but right now not yet. So with the alias easy tags. So once we have performed this step, we have actually enabled our custom field type, but it's not done yet, so we still have to register the field storage. The external storage, we have to register the indexable class, and we will tag all these services with the same easy tags alias. And once we make it work, how much time do we have, actually?
45 minutes.
45 minutes. Okay. We can register this. So we have easy publish field type indexable, easy tags, okay. There we go. Which is also service. So we just declare a class and we need to tag it. With the name easyPublish field type indexable. And we also have the external storage service. With the easyPublish field type, easy tags, external storage class, and name field type external storage, right? External storage handler, I would say. Yeah, that's it. Okay, so these will be our base services for the fields. And you will pretty much have to do this for every field type that you implement.
Well, not every. The most of the field types will only require the one service, the tag type service, because it doesn't have any.
If they don't have any external storage, of course you won't have to declare external storage, and if you don't want it to be indexable for some reason,
you just provide a service that aliases the non-indexable. I think it's called unindexed.
Yeah, exactly.
So there's a class in easy kernel that's called unindexed, which you can use as an implementation of the indexable interface when you don't want your field type to be searchable.
So unindexed, is that it? I think so. Yeah. So if you didn't have the implementation for the indexable class, you can simply pass this as the class, and you will prevent anything from breaking. If for some reason somebody invokes the search on the search criterion for the search service on this field, it will throw an exception if you don't have this defined.
Because when you are developing, you want to do this.
Yeah. Yes. Okay, for the next part, since we had a tag service, we are also including that, but I think I will just skip that. The PAPI YAML file. So if we are using an external service, of course we can declare it in the services YAML, but on the other hand, if you just want to separate this from the rest of the code, you can always create like this file PAPI, meaning public API or something like that. Also, we have implemented the legacy storage converter, so we also need to register it. So, now we said that we can have multiple storage engines, so sort of convention is to, if you want your code to be, your configurations to be neat and clean, that you separate those services for the legacy converter in separate, YAML configuration files, and then simply add them or enable them as you will. So I will create the storage engines folder I say it's just a convenience. And I will declare another file which is called legacy.yaml. And here I will define the easy publish field type easy tags converter class, which is what was it called? Okay, let's just go with the full path then. App bundle core. Yeah, I don't know the path. Core filter. Let me just. No, the wrong one. Persistence legacy converter tags. That's the one. So, where is it right now? Legacy converter tags. Okay, and I will also need to declare the storage gateway here. So, easy publish field type. Easy tags, storage gateway, class is the one I initially opened, so the legacy storage yeah, that's the one. Give me a break. Okay. Now the services easy publish field type easy tag converter. I'm missing full stop here. Okay, and of course the tags. Where the name is set to the easy publish what is it, storage engine, right? Storage engine, and we will also give it an alias easy tags, and I think that it also requires the lazy load and the stuff creates. I'll check that. We'll be back to this, and we also have the storage gateway. Where we have the class, yeah, and the tags. Oh, there we go. With the name easy publish field type external storage. Yeah, I think this is it. External storage handler. And storage handler gateway. Which one is gateway? Ah, there we go. The alias easy tags, and we have to give it the identifier legacy storage. Okay, so these are all the services. What? Missing arguments. Ah, of course. So we have the constructor which accepts language handler from the easy publish SPI persistence content language. So this is exposed already. Let me just say here the arguments. It is the easy publish dot SPI persistence legacy language handler. Yeah, that's it. Okay, so now we have declared them all, and now we need to interconnect all those settings with the within the dependency injection app extension. So we will simply load all those files that we have declared in the YAML file loader. The order is not important, I think. It will be resolved. So we will just load the field types.yaml. Did I name it correct? Yeah. And we will also add the storage engines / legacy.yaml. Okay, so that solves the services for the field type. We still have the templating to do. The templating is usually implemented in the resources. So resources views, we'll create a new directory views, and we will define the HTML twig for rendering the tag fields. So we can name it any way we want. In the default tags bundle, it is called easy tags content fields.html.twig, and in here we will define the twig block which will render out our fields. So
the important thing is the name of this block. It needs to be named as field type identifier, which is easy tags. Underscore, yeah. I think, field.
Yeah.
Yep.
I think so. So easy tags fields. And now we have the template. We will render it out. We can simply, at this point, we can simply output the field value if you check if you check the default implementations for the Vue templates, I don't know, but you have probably all been digging through the Easy Platform bundles and core at some point. So if you see the fields, Easy Systems, kernel, Easy Bundle, core bundle, right? Resources, views. So here you have the block. They follow the same pattern. So the identifier underscore field, and they simply output values or are invoking some other sub blocks. But in this template, you will by default have the field objects, and this field objects, if you invoke .value, you will actually get the value objects that you defined in the value methods. So in our case, we will write out, for example, for each for tag in fields.value.tags, and if you remember, the tags array actually contains the tag objects, so we can simply go and for each tag output the property keywords from it. In some simpler cases, you would have the value straight in the value object, but since we are passing the tag objects, we can say tag dot keywords pipe. Where are you? Oh. Tag keyword row, and of course we can, I don't know, do some unordered list here, so it looks a bit prettier.
There's an error. You're using the wrong print. You're using the wrong tag for printing. Twig tag.
Really?
It's
Hold on.
I don't know how it's in English.
What?
You don't without the percent signs. It's double brackets.
Yeah, exactly.
No, not there. Not there. The below.
Lower. Yeah.
Yeah.
Thanks. Yeah, this is the output. Okay, so we'll just put it in the list item. And that should pretty much do it. And then we have to register these templates, which we'll do by adding the another config file, the easy publish YAML. Easy publish.yaml. And in here we can define the block which says system default. In a lot of field types that we saw that people actually when people actually re-implement the data type, I don't know what was the reason for it, but a lot of people were using a global scope here instead of default, and it would create so much unwanted and unneeded troubles.
They probably put it because they think that global means all site accesses.
Yeah.
Well, it does, but the default means also all site accesses.
Yeah.
And if you put it in global, it'll just override everything else, and all other field types will lose their templates.
Yeah.
So it just take care that you specify always the default scope.
Yeah. So we have a setting which is called field templates, and you can define it like this. So the template is the one that we created. So the app bundle, and we are linking to the easy tags underscore content underscore fields dot html dot twig. There we go. And we also need to set the priority for the tag template. So when the site is loaded, it will the field template resolver will take all the field templates, and based on this priority, it will define the order of the templates, order in which the templates are loaded, and ones with the higher priority will get to be loaded as a top priority and displayed outside. The other way to do it probably would be if you absolutely know that you have like one template which is the definite where all the field types in your app is defined. You can always extend that template, but and then redefine the field that you want or define the new one. But it's the common practice to do it like this. The extending is perhaps a better solution when you just want to extend the existing template functionality or add something new, but within some project, but not for the permanent state. Okay, so we need to define priority. Let's say 10, anything greater than 0. Of course, if you have a lot of template overrides and define them all as 10, and you have the same fields, the same field block in all of them, it's gonna be a bit unpredictable, but okay. Okay, so the easy publish YAML file is inserted not only by loading, but it needs to be prepended. Let's just check any of bundles that you have on the easy. If you're wondering how to do this, for example, I mean I can show you on the real text bundle. So in dependency injection, of course, we have a lot of stuff that is not included in this workshop, as you can see. Eddie was a busy bee. We have to define the prepend methods, where we will define which files we want to prepend. So basically, I will simply copy this text to speed things up a bit. So we want to inject only the easy publish YAML for now. Look, it's easy platform UI. And then we will simply, iterate through them and define a path to the config file and get its contents, and then prepend the extension configuration to the main configuration of the app. And basically, that's the way to do it for the easy publish, because we have the main easy publish file in the root folder, and we want to add these settings on top of it. So once we have done this, I think that we should be able to render the tag. I don't think I have skipped pretty much anything, but let's just check it out. Step 9 was the thing that we're declaring, yeah. And we have implemented parameters, we have implemented views, yes, that's right, that's it. Okay, so I have prepared the storage where I have removed, just for this demonstration, I had to remove the easy reach text field at that moment because I wasn't able to, since we haven't implemented the easy platform UI interface for tags completely. I had to add the tag field via the admin interface, but when I tried to edit class in the admin interface, I couldn't edit it because easy reach text doesn't exist as a legacy data type. So I have simply removed it from all the classes, replaced it with text block field with the same identifiers, so the thing will work, but it will not crash, but it will be empty, and added tags. So basically, I'm having trouble with VirtualBox right now. I think that you shouldn't have the same problems as me, but let me just run this. Okay, let me just demonstrate it here. Yeah.
Increase the font size.
I will. So, Chrome, where's Chrome? Okay. So I'll just try to open it locally, because the code is pretty much the same. So I have added the tags field on the blog post class, and I have added some dummy tags just so we could have something to output. Is it on a Vagrant local? What? Yeah, but they opened the. No, wait. Where are the tags? Perhaps I'm in the wrong step. It is possible. Step 8, register services. Step 9, create template. Yeah, exactly. So I was on the wrong step. And these are probably caches. Okay. Oh, there we go. And we have rendered templates with the H2, and this particular article has a tag called sports. So we have done it. We have made a readable field type. Okay. And for the rest of the workshop, I just wanted to show you that once you have the once you have implemented this, you are able to use it through the API. So we still, at this point, you have the fully functional field type, which is readable and writable, but you still don't have the interface for the platform UI. So what I wanted to show you is that you can, for example, define Symfony command, or you can use this field in any sort of controller you want to update fields, to create new values and store them, or to remove them and stuff like that. For example, let me just quickly go to the admin. Since we have the tag service, I will just show it to you right now, or have I already? It's fairly complex code, but it allows us to load tags and to pass them through as values. So, okay, this is not admin. What have we called it? It should be /admin. Is it? Oh, it is. easy pub. Just publish, right. So 5 things to consider. So I don't know. I have these dummy tags here. Web development, doesn't matter. I have created the, in master branch, you might find a Symfony command which shows how you can programmatically fetch the field value. So in PHP, how you can fetch the field value, how you can display it as an array or return an object or use the toHash value to display it as a hashable, serializable content, and I have also made the steps, the update struct where I can pass another tag and replace the original content in the next version. So let me just show it to you. For this purpose, I had to enable the original NetGen tags because the tag service and all the layers that apply to it are a bit outside of the scope of this workshop, but purely for the demonstration purposes. I have this simple command where I fetch content and display it, and then I load the admin user and I store the new value. So basically, you can see that when it comes to tags, oh, you don't see anything. Yes, sorry. Let's go like this. Can you see it? No? Okay. So basically, when it comes to reading the fields, it's actually nothing special. It's pretty much the ordinary, you follow the procedure that you already have in the Easy Publish. So you get the field helper, you get the translation helper service, you can load the content, check if there is a field tags and if it is empty using the field helper service, and then you can get the translated fields using the translation helper service. If you want to access the actual value, you call field value. This will return you the thing that the object that you have defined in the value file. So it will have one property and it is tags. You can also get the field type identifier by invoking, your call to when you load the field definition. You can get the field type, and then by doing this, you get the access to the type PHP, and you can use all the methods that are stored in there. So, for example, toHash, if we want to use it in program, we will fetch the field type using the field type service, and then we will be able to invoke that method. Also, you can get the tags from the value objects. You can iterate through them and output the keyword property, which will be pretty much the same thing, to get the actual values. And let's just say how it works. So I have the web summer camp. Where is it? Oh, here it is. Field types test. So basically the content with ID 87, I hard-coded this because, just to be faster. Yeah, it is the 5 things to consider article. So if we display the field hash it will return the structure like this. So this is the thing that we have defined in the two hash methods. So we get a pure array containing all the tags with all the keywords for that tag and in all the languages. So for example, if we had a second language, then we would get another entry in the keywords array, and that was the reason why we had it like a dynamic field. Then if we output the field value, we can see that we get the structure from the value. So tags array containing tag objects. And the structure is pretty much the same as in 2hash, except these are properties and not array elements. And if we want to extract keys from tag objects, that was the part of the code where we just iterate through all tags and output their properties keywords. So right now we have travel and web development. And in the next step, I am invoking the tag service. Sorry, I keep forgetting this small. So in order to, of course, update the object, we need a user who has permission to write the data in easy fields and store and publish easy objects. So we are using the user service to load user. Of course, this is only done in command. Please don't do this in the front controller. It can cause so much trouble. And after we set the user, we are invoking the tag service, so we would be able to load additional tag objects. For example, I have used the method load tags by keywords to get the tag object for the tag sports. And after that, I have created. Okay, so here it is. So after we invoke the tag service, it returns us the tag object for it. And after that, we are simply passing these objects into the update struct. So we create programmatically, we create content service. We invoke the content service and we create content draft. And then we define the update struct, where we just set the field tags to the value of tag. Now, if you remember, the input was validating whether we have the hold on just a sec. The input was validating if we have if the past value is an array. We had this core field type. So create value from inputs. So we are checking if we are getting the array. So if we just pass a single tag object, it will also work. So we either have one single tag object or we have an array of tag objects. So when I'm invoking the when I'm adding this value to the update struct, this method will be invoked at that moment. And after we update, 10 minutes. Okay. And after we update the objects, and that's the last step here. We will see that it worked since after we updated the so publish version. After that, we fetch the translated field tags and it returns us the new value. So the field is both readable and writable. Petar suggested that I try to find the field type API documentation. We have, why doesn't it work? So we have a diagram here, but it's really not very, it's blurry, it's not readable. But basically you can, on the doc easy know, you can find the sequence diagram of the entire workflow for the fields, which is actually a very good reference. So you could get the feel at which point is some part of the code actually executed and what does it do. So, for example, when we invoke the create content from the public API, then the repository content service is used, and it's invoking the methods of accept value, validate. It's communicating with the SPI field type interface. So we first check if the value is acceptable, then we validate it, we get the validator configuration that I was mentioning, and after all these steps have passed, we invoke the toPersistence value where we actually pass the content to to the gateway and the database handler, and then the persistence content handler is invoked. It is calling the field storage, which stores field data, and at the end, the content is indexed if we have the indexable class. So that's pretty much the entire workflow, and it's really good to it's actually pretty useful to have it as a reference when you're trying to re-implement another field type, just so you have a grasp at which moment which method is invoked. And that would pretty much sum it up. Do you perhaps have any questions? If it is anything, if your question is any more complex, you can of course ask me after the workshop. Yeah.
If you add new, yes. So if you add, let's say, new tables like you did,
okay.
Do you have like an installer to create those tables into the database, or what would be the recommended way?
Yeah.
The recommended way would be the SQL
Yeah.
scripts, just like in legacy, because we're not using Doctrine here, Doctrine ORM, so you can't use the Doctrine schema create and Doctrine schema update. So it's just upgrade SQL scripts. Text bundle does provide the upgrade scripts which you can execute to create database tables.
Yeah. That's it?
That's it.
Okay, so thanks for your time, and if you have any field types that you know that are publicly used, I plea for help. Please contribute to the community, rewrite them to the the new stack. Somebody somewhere is trying to use it and crying his heart out because he cannot provide it in an easy platform. It's really useful. It's widely used, and a lot of projects, depending on it, will never be rewritten if we don't do that. So thank you for your time, and for any questions, I'm available later.
Thank you.